So now we're gonna see built-in 3D physics. Unity's built-in 3D physics engine is an integration of NVIDIA physics engine. You can use this engine in object-oriented 3D projects. You can go to your software and pretty much just create a new project or grab whatever project you were working on it and just open it. So we're gonna be dealing with this. So like that. Now, the section includes the following topics. So we have the character control. In the this is the topic in the description. The character control: configure physics-based character control for the first person and third person characters. Then we have the rigid body physics: apply physics-based behavior to game objects. We have the collision: use colliders to configure collisions between game objects. We have joints: apply and configure joints that connect game objects and simulate physical forces for pivoting, movement, and restriction. Articulations: configure complex system of rigid bodies and joints. Ragdoll physics: configure ragdoll physics for characters. Cloth: simulate fabric movement for characters, clothing, and other application textiles. And finally, the multi-scene physics: manage different physics contexts in one project with multiple dedicated physics scenes. So now we're gonna see the next, that is gonna be the character control, and this is just very brief. So character control: in a first person or third person application, a user's character or avatar usually needs some collision based physics so that it doesn't fall through the floor or walk through the walls. In 3D physics, you can create and configure character physics and control with a character controller. You can configure character control via the character controller class or the corresponding character controller component. So we have the introduction to the character control, and then, well, that is the overview of the concept and fundamental behaviors of character controllers and character controller component reference page for the character controller component. So let's keep moving here. So this is very brief introduction to the character control. Yeah, let's jump this one and go straight here. So this is the character control component reference. So the character controller is mainly used for third person or first person player control that does not make use of the rigid body physics. So what we can do right now is go into the scene and let's see. I'm gonna delete this one, and this one as well. So I'm gonna have a clean slot. So and I'm just gonna grab, I don't know, the capsule. Yeah, we have a capsule now. And here I'm gonna click in add component, and I'm gonna just type in controller. So control, and I'm gonna grab this one, character controller. Okay, so here we can change the value. So we have the slope limit, the step offset, the skiing width, mean move distance, center radius, height. So we can move this one, I don't know, maybe 90. We can leave this one, let me see. Okay, yeah, 0.5 is the radius. Okay, that's fine. And yeah, we can leave it like that for now. But yeah, this is the use for that. So let me see if we can let me see if I can, I don't know, maybe if I pick 5, no, it's too much. So maybe just 2, okay, or just 1.5, something like this. So if we zoom in, as you can see, we're gonna see this character controller. So and we're gonna see this in more detail. So the properties, as we already seen it here, the properties are: the slope limit limits the collider to only climb slopes that are less steep and decrease than the indicator value. The step offset: character will step up a stair only if it is closer to the ground than the indicator value. They should not be greater than the character controller's height, or it will generate an error. So then we have the skiing width. Two colliders can penetrate each other as deep as their skiing width. Larger skiing width reduces the jitter. Low skiing width can cause the character to get stuck. A good setting is to make this value 10% radius. So let me see. Okay, so we have the highest 2 and 10% of the radius. Okay, the radius is 0.5. Okay, that's fair. And you can play around with these values. So let me see. Okay, so it's focusing. Okay, so the mean move distance. If the character tries to move below the indicated value, it will just not move at all. This can be used to reduce jitter. In most situations, this value should be left at 0. Okay, this is the mean move distance, so that's when the mean move distance. Let me see, yeah, let me see, mean move distance, we just left it at 0, so, oh, well, it's 0 point, let's just put it 0, so, like that, or just 0, so, no problem. Okay, what else do we have here? So we have the center, the radius and height. So the center, this will offset the capsule collider in world space and won't affect how the characters pivots. The radius, length of the capsule's collider's radius, this is essentially the width of the collider, and the height, the character's capsule collider height. Changing this will scale the collider along the y-axis in both positive and negative directions. So yeah, pretty much that's what we have a similar example here. As you can see, this creature, this animation, and we are trapping it, or we have this character controller. I can play around with the values here, maybe 1 here, so I'm moving it, so now 3 or just -1. Okay, so we can, yeah, 0, we can also move it, I don't know, 2, 3, you can play around with these values as well. And if you want to go higher, I mean, if you want to go up, we need to go in the y direction, so I'll put it 2, like that. And if you want to put yeah, 0.2 maybe, or 0.1, yeah, you kind of see it. Let me see, just put 0. If I put just 0, you I don't think I don't think you can notice. Yeah, you can kind of notice it. Maybe if you go here and just go into frame. Okay, if I go into the shading mode, into the shading mode, and I just grab, what happened? Okay, and I just check wireframe, you kind see it, the controller, the character controller, that is pretty much in the same position as the cylinder, is in the 0, 0, 0. Okay, and the x0, y0, and z0. So if I go into the shader frame, you kind of don't see it. This one kind of you see it. Yeah, okay, if you go to overdrone as well, you can do that, so we can leave it like that for now. Okay, so some details. So the traditional Doom style first person controls are not physically realistic. The characters run 90 miles per hour, come to a halt immediately, and turns on a dime. Because it is so unrealistic, use of rigid bodies and physics to create this behavior is impractical and will feel wrong. The solution is the specialized character controller. It is simply a capsule-shaped collider which can be told to move in some direction from a script. The controller will then carry out the movement but be constrained by collisions. It will slide along walls, walk up stairs if they are lower than the step offset, and walk on slopes within the slope limit. The controller does not react to forces on its own. It does not automatically push rigid bodies away. If you want to push rigid bodies or objects with a character controller, you can apply forces to any object that it will collide via the on-controller collider hit function through the scripting. So C# involving here. On the other hand, if you want your player character to be affected by physics, then you might be better by using rigid body instead of the character controller. Now a little bit of fine-tuning your character. You can modify the height and radius to fit your character's mesh. Okay, it is recommended to always use around 2 meters for a human-like character. You can also modify the center of the capsule in case your pivot points is not in the exact center of characters. Step offset can affect this too. Make sure that this value is between 0.1 and 0.4 for 2 meter size human. A slope limit should not be too small, often using a value of 90 degrees to work best. So that's what I did here. I think, yeah, 90 degrees here. Let me see. The character controller will not be able to climb up walls due to the capsule shape, so 90 degrees. Don't get stuck. So the skin width is one of the most critical properties to get right when tuning your character controller. If your character gets stuck, it is most likely because your skin width is too small. The skin width will let objects slightly penetrate the controller, but it removes jitters and prevents it from getting stuck. It's a good practice to keep your skin width at least greater than 0.01 and more than 10% of the radius. So let me see, 0.01. Okay, yeah, I have it at 0.08 by default. Okay, now we recommend keeping a mean move distance at 0. Yeah, we already did that. And yeah, there are some hints here, but now let's go back to the introduction to the character control. So again, it's just very brief introduction to character control. The character in a first or third person game usually needs some collision based physics so that it doesn't fall through the floor or walk through walls. In many applications, the character's accelerations and movement are intentionally not physically realistic so that the character can accelerate, brake and change direction almost instantaneously and without being affected by the momentum. So that's very difficult to do in real world. In 3D physics, this type of behavior can be created using a character controller. This component gives the character a simple capsule-shaped collider. So this is the one that we are talking, and I'm gonna give it 2. And now let me see, F. Now you can see this is the capsule capsule-shaped collider that is always upright. The controller has its own special functions to set the object's speed and direction, but unlike true colliders, a rigid body is not needed and the momentum effects are not realistic. A character controller cannot walk through static colliders in a scene, and so will follow floors and be obstructed by walls. It can push rigid body objects aside while you're moving, but will not be accelerated by incoming collisions. This means that you can use the standard 3D colliders to create a scene around which the controller will walk, but you are not limited by realistic physical behavior on the character itself. And you can check out more information in the reference page. And yeah, this is pretty much all that we have for the character controller.